This is Unit 2, Topic 7, Calculations for the Binomial Distribution. In this topic, we are not going to discuss any new material regarding the binomial distribution. We are only going to be practicing some more complex versions of the calculations that we began in Topic 6. And then the only thing that we are going to do that's new, although it's not new material, is finding the mean and standard deviation for a binomial distribution scenario. There are two problems in this PowerPoint. We are going to be going over the first one. The second one is almost identical, so I'm going to leave that as extra practice for you to do. In addition to this, this is the last topic in this unit. And there is a practice exam that's up on Moodle. It is just for your own practice, but it is going to be pretty similar to what the exam would look like. So I definitely recommend going through that and using that for practice. So the first example is just kind of a mock example. 60% of computers sold by a large computer retailer are laptops and 40% are desktop models. The company randomly selects 12 purchases made at a certain store over the course of a year. So this would be something where they are maybe interested in evaluating different aspects of purchases. So maybe there was certain sales that were going on at the same time as the purchases, or maybe certain salespeople had different luck or, let's say, skills with selling computers. So explain how this can be represented by the binomial distribution. So this is where the acronym BINS would apply. So B for binary, there are two outcomes, either buying a laptop or a desktop. Independence is going to be taken care of since the people are randomly selected. There is a fixed number of 12 purchases that they're going to be looking at. And the probability of success is either 60% or 40% depending on the focus. Now, since it's a large company, one order taken out and being removed from consideration is not going to affect the probability. So this is actually that 5% guideline rule, but kind of in an invisible state. So this represents the binomial distribution since all of the requirements are met. Find the probability that 8 customers purchased a laptop. So as we go through these, we are going to be looking at the table, which you will have for your exam, and then the software, which is, I'd say, a lot more realistic and more flexible. So we're going to be looking at both of those for each of these examples. So using the tables, we have 12 trials. So I'm going to go to the page that has 12 trials. And I'm going to choose the row that has 12 trials with 8 successes because that's what we're looking for here. So that's going to be just this row specifically. And I'm going to choose the cell that has a probability of success. Let's see, we're looking at laptops, so that would be 60%. So the probability of a person, if they randomly selected 12 orders, 8 of them purchasing laptops would be 0.213. If you did this problem in Stata, you would go to the binomial calculator under exact statistics. And so we have 12 trials, we want 8 successes, and there is a 60% chance of success, which in this case is purchasing a laptop. So the observed success is the one that we will be using as our answer. So that is 0.212841. Now, Stata is obviously going to give us more decimal places than we can get with the table. So that's one of the advantages that the technology will offer us as well. And of course, your other option is using the command box. And so depending on which one you like, completely up to you, On the exams, again, you will have no choice but to use the table, and you will be given the pages of the table that you'll need for the test. So 60% of computers sold by a large retailer are laptops, 60% are desktops, so it's the same example. And the probability that at most 8 customers purchase a laptop. So at most 8 is going to be 0, 1, 2, 3, 4, 5, 6, 7, or 8. So what you'll find is that with the table as well as the drop-down menu, you're either going to have a lot of calculations ahead of you, or you're going to have to be very familiar with the notation that we get. We actually don't need to do anything new with the drop-down menu. If you wanted to use the table for this question, you would have to, and there's nothing wrong with this, but you would have to add up these 8 probabilities. So 1, 2, 3, 4, 5, 6, 7, 8, 9 probabilities because I left out 0. So to make sure that we're on the same page, I'm going to actually display what would go into the calculator here. So first is that these first 2 are going to go into your calculator as 0, or you can just leave them out. So when we add these 9 values, we end up getting 0.774. If you, again, just left off these 2, nothing different would happen because they're going to just go in as 0. In Stata, we actually get a number of different things that it gives us as an output. One of these is actually our answer. So another way that we could write this is that most 8 customers is less than or equal to 8, which is actually what this row gives us. So depending on how savvy you are, you may decide to just, use this output as its maximum, because you could probably get a lot of information from this. Now notice they're always less than or equal to, greater than or equal to. So you may have to make some adjustments in other situations. If I was doing this with the command box, I wouldn't put a P here. This would be just the binomial command. So what the binomial command is if you look back in the topic 6 notes, we did mention this briefly, is the binomial command gives us the probability from 0 to whatever we put in for a number of successes. So for example, when I put in 12, 8.6 or 0.60, this is giving me the probability of 0 to 8 successes. So when I do this, I'm going to get that same 0.7746. And so notice these are rounding differently. This is, again, because this is rounding to 3, and so this is what the number would be out fully. So this actually in the table rounded multiple times because you added up multiple things that were rounded. That's okay. It's going to be a very small difference. So if you had reported this from Zeta, you would actually want to call this 0.775. And again, rounding differences are small, but they will be there. So again, this is from 0 to 8 successes. So it's taking all of these 9 probabilities and is adding them up. So find the probability that fewer than 8 customers have purchased a laptop. So fewer than 8 is really similar to what we just found, except for it doesn't have the last probability that we had in there. So instead of 0 through 7, 0 through 8, it's 0 through 7. So if we go back to the previous slide, we could just take this value and subtract off the probability of just getting 8. But honestly, it's probably safer to do it again because if you've made a mistake in some of these previous calculations, they're going to continue to appear when you go to this current one. So very similarly, we would add up the probabilities in the table. So I'm not going to do those again, but it would be adding up these 8 numbers here. Or if you wanted to use the drop down in this case, you'd have to have it find something else. So you can do the subtraction as we just discussed. This is a little bit safer since you have the data back originally. I would probably do it again. So I would do 7 successes instead. So that 7 is that emphasized number that happens up here. So this is less than or equal to 7. So that's 0.562. And again, this is because in the table there was rounding in 1, 2, 3, 4, 5, 6, 7, 8 numbers. But the difference is less than 1%. It's actually, it's actually 0.1% is how far off it's going to be when rounded. But it's off by less than that if you compare it to the unrounded number. If I were to do this using the display commands, I would use the binomial command. So binomial P finds the exact probability of 8. Plain old binomial is 0 to whatever you put in here. So then we would end up with that same answer. So find the probability of between 4 and 7 people purchasing a laptop. Maybe that's what they had expected or projected. So 4 through 7 inclusive is the probability of 4, 5, 6, and 7. So just because the answer has appeared here doesn't mean anything, because you have to be able to actually come to that answer. So if we did this using the table, and I think the table in this case might actually be the nicer way. But what if it was, out of 1,000, you wanted 100 to 200? Then the table wouldn't be very realistic. So you would add up these 4 numbers for using the table, which is pretty nice. If you were using the drop-down menu, you'd have to do a few things. And this is where I actually think that using the command box may be more straightforward. But it's very personal. So we already know the probability of the less than 7. So that's 0, 1, 2, 3, 4, 5, 6, and 7. Now we want 4, 5, 6, and 7. So what we can do is we can subtract off 0 to 3. So that'll give us everything we want plus some extra, minus the part that we don't want, which would be less than or equal to 3. So just to show again, 0.561822, let's just use all the decimal places since we have it. This is 0, 1, 2, 3, 4, 5, 6, and 7. So this is everything that we want plus 0, 1, 2, and 3. Well, we're able to find 0, 1, 2, and 3, and we can subtract that off. So we end up getting 0.546555. which is basically what we end up with the table, so the rounding ends up kind of evening itself out. If you did this using the binomial commands, you could have done it in one step. After you put display, you can have Sata do numbers of different calculations. So let's see, we want to get a 3. So we can have it do that. If you want, you also can have it do the probabilities individually. You don't have to do spaces. I think it just helps for organization for me personally. So it isn't a lot to do 4 of them, but if there was maybe 50 of these, you definitely need to consider using some kind of technology. So whichever way you do it is up to you. It just depends on which one you are more comfortable with. Before I get to... Oh, no, this is what you want. All right, so find the probability that 8 or greater customers purchase a laptop. So 8 or more is 8, 9, 10, 11, or 12. Now, this is where I think the drop-down ends up being more convenient. So we're looking for greater than or equal to 8, we already have this output down here, which is pretty convenient. So this is going to be 0.438. Now, if you are using the table, you could just have added up all of these values here. If you're using the command box, you're going to have to use this bottom line here. Because 8, 9, 10, 11, and 12, if you put an 8 here, this is going to be 0 to 8. So ignoring my 1 minus for now. If you put an 8 here, that's 0 to 8. That's kind of the opposite plus some extra of what we actually want. But we can use the complement here and say, oh, okay, I want the opposite, 1 minus the opposite of 8 to 12. So instead, you can do 1 minus 0 to 7. So again, this is where I definitely think the dropdown might be easier, which is why a hybrid might be better for some people. But whichever one you use, you're never going to have to use data on an exam, which is a pretty big advantage. You have the ability to take your time and do whatever you are most comfortable with. So the remainder of the PowerPoint goes through a practice problem that is almost identical to this. I'm going to leave this up as practice. The only thing we have left to do is to find the mean and standard deviation for this scenario. So find the mean and standard deviation if we are focusing on laptops, which is what we've been looking at the whole time. So the mean is n times p. Now think about what this actually means. This is taking your sample size and multiplying the probability of success. So in this case, I'm saying, hey, I expect 12 out of 12 of these sales that 60% of them would be laptops. So n times p is kind of what you might think of even if you didn't want to call it the mean. So hey, how many laptops do you expect to sell out of these 12 orders? Well, 60% of them, because in general, that's the amount that, the percentage that is laptops that are sold. So this is 7.2 people when you would do that multiplication. The standard deviation is a little bit more complicated, but the standard deviation sigma is the square root of n times p times q, which is equal to the square root of 12 times 0.60 times 0.40. When you perform that, you end up getting 1.697. And so the original data is just whole number of people, so I would only include one more decimal place on this. If you included more, that would be completely fine, but we only need 2 of them. So now, the following example goes through something pretty similar, but with the survival rate of people who have received open heart surgery at age 65 or older. So if you have any questions about these, please feel to email me. There is also more practice for this type of question on the practice exam. Let me know if you have any questions.